Antarctica stands alone, a continent of ice and mystery at the very bottom of our world. It is a place of extremes, the coldest, driest and highest continent on Earth, a realm so alien that it challenges our very understanding of life and survival. Unlike any other landmass, it belongs to no single nation. Instead, it is governed by an international agreement, the Antarctic Treaty, signed in 1959 at the height of the Cold War by 12 countries with active interests in the region. The treaty entered into force in 1961, and today over 50 nations are signatories, representing the vast majority of the world's population and economic power. This unique political arrangement makes it the only place on our planet ruled not by a government but by a collective promise to preserve its pristine nature, a global commons dedicated to knowledge and cooperation. The Antarctic Treaty was a landmark in international diplomacy. It set aside the entire continent for peaceful purposes, explicitly banning military activity, nuclear explosions, and the disposal of radioactive waste. The treaty also established freedom of scientific investigation and promoted the exchange of research and data, making Antarctica a living laboratory for the world. Access to this frozen world is not a simple matter of booking a flight. It is one of the most heavily restricted destinations imaginable, and for good reason. For those who wish to step foot on its icy shores as a tourist, the journey is long and prohibitively expensive, often costing tens of thousands of dollars. The process involves securing permits months in advance through specialized tour operators who must adhere to the stringent regulations set by the International Association of Antarctica Tour Operators. These rules are designed to minimize human impact, allowing only a small number of people ashore at any given time, all under the watchful eye of guides, who ensure that every footstep leaves the lightest possible trace on this fragile landscape. For scientists and independent adventurers, the hurdles are even higher. An expedition requires a permit from one's home country, a process that involves submitting a detailed environmental impact assessment to prove the mission will not harm the continent's unique ecosystems. Furthermore, they must secure costly search and rescue insurance, a necessary precaution in a land where the weather can turn deadly in an instant and help is thousands of miles away. This intricate web of regulations, while appearing bureaucratic, serves a crucial purpose. It acts as a shield, protecting Antarctica from the uncontrolled exploitation and environmental degradation that has scarred so much of the rest of our planet, preserving it for future generations of researchers. The treaty's success has inspired other international agreements, such as those protecting the Arctic and the world's oceans, and is often cited as a model for peaceful cooperation in contested regions. Yet this system of governance has also fueled a sense of intrigue and suspicion. The high cost and complex bureaucracy effectively keep the vast majority of the world's population away, leading some to question the true motives behind such tight control. While environmental protection is the stated reason, the sheer difficulty of access has given rise to countless theories about what secrets the ice may hold. Is the international community simply protecting a delicate ecosystem, or are they guarding something far more profound? This question hangs over the continent, adding another layer of mystery to a place already defined by its remoteness and its vast, unexplored expanses of white. The Antarctic Treaty remains a testament to what humanity can achieve when nations choose cooperation over conflict, and when the pursuit of knowledge is placed above territorial ambition. Its legacy continues to shape not only the fate of Antarctica, but the future of international relations on our fragile planet. One of the most enduring and perplexing mysteries surrounding Antarctica is the existence of maps created centuries before the continent was officially discovered in 1820. These ancient maps, shrouded in legend and controversy, have fascinated historians, cartographers, and conspiracy theorists alike. The most famous of these is the Piri Reis map, a stunning piece of cartography compiled in 1513 by Piri Reis, an admiral of the Ottoman Navy. The map is only a surviving fragment, but it has sparked debate for decades due to its remarkable detail and the sources from which it was drawn. Discovered in a Turkish palace in 1929, the map astounded historians and scientists alike. Its origins trace back to a time when much of the world was still uncharted, yet it seemed to contain knowledge far beyond its era. The Piri Reis map appeared to show the northern coastline of Antarctica, a landmass that was supposedly unknown to the world at the time. Even more astonishing, the map's depictions of South America and Africa were uncannily accurate for the early 16th century. Piri Reis himself noted on the map that he had compiled it from much older source maps, some of which he claimed dated back to the time of Alexander the Great in the 4th century BC. These sources, now lost to history, raise questions about the transmission of ancient geographical knowledge. The truly bewildering aspect of the Piri Reis map is not just that it depicts Antarctica, but that it seems to show the coastline as it would appear without its immense ice sheet. This detail has fueled speculation that the map's sources may have originated from a time when Antarctica was ice-free, thousands of years before our current era. In the 1960s, the United States Air Force conducted seismic surveys of the continent using modern technology to map the bedrock hidden beneath miles of ice. Their findings would add a new layer to the controversy. The results of their surveys bore a startling resemblance to the coastline depicted on the 500-year-old map. This uncanny similarity has led some to argue that the Piri Reis map preserves knowledge from a lost civilization with advanced surveying abilities. This raises a profound and unsettling question. Who could have possessed the knowledge and the advanced surveying technology to accurately map the Antarctic continent during a time when it was free of ice, a period that science tells us ended thousands of years ago? The debate continues, with skeptics suggesting the similarities are coincidental or the result of misinterpretation, while others see evidence of forgotten history. The Piri Reis map is not an isolated anomaly. Throughout history, other maps have surfaced that seem to depict Antarctica or other unknown lands with surprising accuracy. Another cartographic puzzle is the Oronteus-Phineus map of 1531. Created by a French mathematician and cartographer, this map has also drawn attention for its depiction of a detailed, largely ice-free Antarctica. This world map shows Antarctica in great detail, positioned near the South Pole centuries before the continent was officially charted by explorers. Like the Piri Reis map, it depicts a largely ice-free continent. The Oronteus-Phineus map even includes rivers and mountain ranges, features that would only be confirmed by modern science centuries later. It illustrates mountains, valleys, and even flowing rivers with a degree of accuracy that seems impossible for its time. Some researchers argue that these features align with subglacial formations discovered only through 20th century radar surveys. These features align remarkably well with subglacial topography discovered only in recent decades using ground-penetrating radar. The accuracy of these ancient maps continues to baffle experts. The map suggests a sophisticated understanding of the continent's geography, a level of knowledge that should not have existed for another 450 years until our own modern era of scientific exploration. The origins of this knowledge remain hotly debated. These ancient maps challenge our conventional timeline of human history and exploration. Some believe they are evidence of lost civilizations or advanced ancient cultures, while others insist they are the result of creative guesswork or misinterpretation. They present us with a paradox, evidence of advanced geographical knowledge existing long before the technologies we believe are necessary to acquire it. The controversy continues to fuel both academic research and popular imagination. Could there have been an ancient seafaring civilization with global reach, one that mapped the world with incredible precision and whose records were passed down through the centuries only to be partially preserved in these later maps? Or are these maps simply the result of remarkable coincidence and the human tendency to find patterns? The possibility is tantalizing. Each new discovery adds another layer to the enigma, inviting us to question what we truly know about our past. These artifacts are not just old drawings, they are whispers from a forgotten past, hinting that the history of our planet and our place within it may be far more complex and mysterious than we currently believe. The ancient maps of Antarctica remain an open invitation to explore, to question, and to wonder. Buried 2.5 miles beneath the East Antarctic ice sheet lies a secret world, a place of utter darkness and crushing pressure that has been sealed off from the surface for over 15 million years. This isolation has made Lake Vostok a unique natural laboratory for scientists seeking to understand the limits of life and the history of our planet. This is Lake Vostok, a freshwater lake roughly the size of Lake Ontario, one of the largest and most mysterious lakes on Earth. Its vastness and isolation have made it a focal point for scientific curiosity and exploration. Its existence was first suggested by seismic soundings in the 1970s, but it remained a theoretical wonder for decades. Later, satellite radar and ice-penetrating radar confirmed the presence of this hidden body of water, sparking a new era of Antarctic research. Russian scientists at Vostok Station spent 20 years painstakingly drilling through the ancient ice, a monumental effort to reach this hidden realm without contaminating its pristine environment. Their work required the development of new sterile drilling techniques and international collaboration to ensure the integrity of the samples. In 2012, they finally broke through, opening a window into a lost world. The moment was celebrated globally as it marked the first time humans had accessed a subglacial lake of this magnitude. What they discovered was nothing short of revolutionary. The samples revealed a complex and dynamic environment, challenging previous assumptions about what could survive in such extreme conditions. The water of Lake Vostok, though ancient, was not sterile. It teemed with life, but not life as we typically know it. DNA analysis revealed a surprising diversity of microbial species, some of which are unlike anything found elsewhere on Earth. In this extreme environment, without sunlight for photosynthesis and isolated from Earth's atmosphere, unique forms of microbes have evolved. Some researchers believe these organisms may have been evolving independently for millions of years, providing a living snapshot of ancient Earth. Scientists have identified at least 17 species that appear to be new branches on the tree of life, organisms known as extremophiles that have adapted to survive under conditions we once thought impossible. Ongoing genetic studies continue to reveal new lineages and metabolic pathways. They exist in total darkness, under pressures hundreds of times greater than at sea level, and in water supersaturated with oxygen, a combination that would be toxic to most life forms on the surface. Some theories suggest that the high oxygen content may be the result of long-term isolation and unique geochemical processes beneath the ice. These remarkable organisms offer profound insights into the sheer tenacity of life and its ability to adapt to the most hostile corners of our planet. Their resilience is now the subject of intense study, with researchers investigating their potential applications in biotechnology and medicine. Instead of relying on sunlight, these microbes have developed alternative survival strategies. Some use chemical energy from the minerals in the lake, while others may rely on ancient organic material trapped in the sediments. They engage in chemosynthesis, deriving their energy from the minerals and chemicals dissolved in the water around them. Recent research has identified metabolic pathways that allow these microbes to process iron, sulfur, and even methane, hinting at a complex web of chemical interactions. They are thought to feed on the rock bed of the lake itself, transforming metals and compounds in ways that scientists are only just beginning to understand. Some studies suggest that these processes could influence the chemistry of the entire lake, creating a self-sustaining ecosystem. The discovery of this isolated, self-sustaining ecosystem has completely rewritten the rules for where life can exist, both here on Earth and potentially elsewhere in the cosmos. Theories now abound about the possibility of similar life forms existing in other extreme environments, both terrestrial and extraterrestrial. The implications of Lake Vostok's hidden biosphere are vast. Ongoing research includes the search for viruses, fungi, and even multicellular organisms, as well as the study of ancient climate records preserved in the lake's sediments. If life can thrive in such an extreme, subglacial environment on our own planet, it raises the tantalizing possibility that similar ecosystems could exist on other worlds. Some scientists are now developing robotic probes and sterile drilling techniques inspired by Lake Vostok research, hoping to one day explore the oceans of distant moons. The icy moons of Jupiter and Saturn, such as Europa and Enceladus, are now seen as prime candidates for extraterrestrial life, as they are believed to harbour vast liquid water oceans beneath their frozen surfaces. The study of Lake Vostok provides a blueprint for how we might search for life in these alien seas. The bizarre, resilient microbes of Lake Vostok serve as a terrestrial analogue, a proof of concept that life does not require sunlight or a temperate climate. Their genetic and metabolic diversity continues to surprise researchers, fueling new hypotheses about life's adaptability. It only requires liquid water, a source of energy, and time, making the dark, cold depths of space seem just a little less empty. As new discoveries emerge from Lake Vostok, the boundaries of our understanding continue to expand, reminding us that the most profound secrets may still lie hidden beneath the ice. In the heart of Antarctica lies one of the most desolate otherworldly regions on our planet, the McMurdo Dry Valleys. Here the landscape is so stark and barren, it's often described as the closest thing to Mars on Earth. Jagged mountains rise above vast, gravel-strewn valleys, and not a single tree or blade of grass breaks the monotony. The air is so dry and cold that snow and ice barely cling to the ground, leaving behind a haunting, windswept expanse that seems untouched by time. Amid this frozen desert, a truly alien spectacle unfolds. From the stark white face of the Taylor Glacier, a crimson waterfall oozes forth, staining the ice in a gruesome display that has earned it the name Bloodfalls. The sight is both mesmerizing and unsettling, a vivid red stream pouring over the pristine ancient ice, as if the glacier itself were bleeding. For decades, the source of this macabre flow was a scientific enigma. Early explorers and researchers speculated that red algae might be responsible for the color, but the true explanation would prove far more extraordinary. The truth, however, is far stranger and more profound than anyone imagined. The blood-red color is not the result of surface biology, but a dramatic interplay of geology, chemistry, and hidden life deep within the glacier. Beneath the ice, a secret ecosystem has been sealed away for millions of years, isolated from the outside world. The source of Bloodfalls is a subglacial lake, a pocket of extremely salty, iron-rich water that has been trapped beneath the Taylor Glacier for an estimated 5 million years. This brine is so salty that it remains liquid even in the frigid Antarctic temperatures, defying the ice that entombs it. Cut off from the atmosphere and sunlight, this ancient brine forms an environment completely devoid of oxygen. It is a world in perpetual darkness, where life must find a way to survive without the energy of the sun. Over millennia, the water has leached iron from the underlying bedrock, becoming saturated with dissolved iron ions. This process is a slow, relentless chemical dance between rock and water, hidden beneath the glacier's icy armor. When this iron-rich water finally escapes through fissures in the glacier and meets the air for the first time in millions of years, a dramatic transformation occurs. The iron rapidly oxidizes, essentially it rusts, turning the water a brilliant blood-red hue. This striking chemical reaction is what creates the illusion of a bleeding glacier, a vivid reminder of the powerful forces at work beneath the Antarctic ice. Yet what makes Bloodfalls truly extraordinary is not just its color, but the life it harbors. This trapped, oxygen-free brine is far from lifeless. Within this extreme environment, scientists have discovered a unique community of chemosynthetic bacteria, microbes that thrive without sunlight or oxygen. These extremophiles have evolved ingenious metabolic pathways, allowing them to survive in conditions that would be lethal to most known life forms. They are living relics of a primordial Earth, adapting to a world of darkness and salt. Instead of relying on photosynthesis, these bacteria use a process called chemosynthesis. They extract energy by metabolizing sulfate, using it as a substitute for oxygen in their respiration. In this process, they reduce sulfate and metabolize the scant organic matter trapped with them, cycling ferric ions from the bedrock as part of their unique energy system. This is a remarkable example of life adapting to the harshest of environments. These bacteria are living time capsules, preserving a record of ancient ecosystems that have persisted in total isolation for geological ages. Their existence offers a window into the distant past when Earth's environment was far more extreme. The discovery of this self-sustaining, ion-cycling ecosystem beneath a glacier has profound implications for our understanding of life's resilience. It echoes the discoveries made in Lake Vostok, another hidden Antarctic world. The conditions at Bloodfalls, intense cold, perpetual darkness, and a reliance on chemical energy from rocks, are strikingly similar to those believed to exist on other planets, especially Mars. The Martian surface is cold and dry, with iron-rich soil and evidence of ancient water flows. Mars, the red planet, is famous for its rusty, iron-rich soil and the tantalizing signs that liquid water once flowed across its surface. Scientists believe that, like Antarctica's dry valleys, Mars may harbor subglacial or subsurface environments where life could persist. The survival of these Antarctic microbes in such extreme isolated conditions suggests that life could potentially exist in similar hidden refuges on Mars, protected from the planet's harsh radiation and freezing surface. Bloodfalls is more than a geological curiosity. It is a natural laboratory for astrobiology. Here, in this Martian landscape on Earth, we find clues to the possibilities of life beyond our planet and a deeper understanding of the extraordinary adaptability of life itself. Beneath Antarctica's serene and, well, seemingly static exterior of ice, a dynamic and powerful force is at work, one that is only now beginning to reveal its secrets to science. Scientists have detected these massive and, honestly, quite mysterious sources of geothermal activity, with heat radiating from deep within the Earth itself. These geothermal vents, similar to those found on the ocean floor, release not only heat, but also a cocktail of minerals and gases, creating unique chemical environments beneath the ice. Near the South Pole, the measured heat flux is more than double the global average, a truly colossal output of energy amounting to millions of watts, and, frankly, it just can't be explained by conventional geological models. These vents may be fueled by ancient volcanic activity, deep faults, or even mantle plumes that channel heat upward. This internal furnace is melting the ice sheet from the bottom up, creating a complex and largely hidden network of liquid water. The heat from these vents can carve out vast chambers and tunnels, forming a labyrinth of subglacial rivers and lakes. This network lubricates the flow of glaciers and carves out immense spaces hidden from our view, a secret world, really, teeming with unknown potential. Some of these caverns are so large that they rival the world's biggest natural caves, and their true extent is still being mapped. Using advanced ground-penetrating radar and ice core drilling, researchers have managed to peer through the ice and reveal the astonishing consequences of this geothermal heat. These tools allow them to map the hidden topography and even sample the unique chemistry of these environments. They've discovered a vast network of subglacial caverns and voids, some of which are truly colossal in scale, easily large enough to house entire cities. These caverns are often interconnected, forming a hidden landscape beneath the ice that is as dramatic as any found above ground. One such system of caves, discovered beneath the Ross Ice Shelf, is believed to be warmed by a nearby active volcano, Mount Erebus. The volcanic heat not only melts the ice but also creates a unique microclimate within these caves. These caves could be as warm as 25 degrees Celsius, creating temperate oases of rock and water, all sealed within a tomb of ice. The warmth and mineral-rich waters provide the perfect conditions for life to thrive in an otherwise frozen world. Such environments are, prime candidates for harboring unique and complex ecosystems that have evolved in complete isolation for millennia. Around the geothermal vents, extremophile microbes feed on chemical energy, forming the base of a food web that could support more complex life. The existence of these geothermally heated caves presents an entirely new frontier for biological discovery on the continent. Scientists are eager to explore these habitats, searching for new species and studying how life adapts to such extreme and isolated conditions. While life in subglacial lakes like Vostok is limited to microbes, the warmer, more complex environments of these caves could potentially support more advanced organisms. The presence of liquid water, warmth, and chemical nutrients creates a rare combination that could foster biodiversity. Scientists speculate that these hidden grottos might host unique species of mosses, fungi, and perhaps even small invertebrates that have adapted to a life of perpetual twilight, sustained by the heat and chemical nutrients provided by the Earth itself. Some organisms may even exhibit bioluminescence or other adaptations to the darkness and mineral-rich environment. Exploring these caverns is a monumental challenge, but honestly, the possibility of finding a completely unknown ecosystem makes it a tantalizing goal for future scientific expeditions. Robotic probes and remote sensors are being developed to safely navigate and study these extreme environments. This accelerated melting from below, driven by a powerful internal heat source rather than just climate change, adds yet another layer of complexity to our understanding of Antarctica's future. The interplay between geothermal heat and glacial movement could have profound effects on ice stability. The continent's ice sheet acts as a global thermostat and a massive reservoir of fresh water. Its stability is absolutely critical for global sea levels and weather patterns. Any changes in the hidden heat below could have ripple effects across the planet. The discovery of this potent, hidden geological activity forces us to reconsider the forces shaping the continent's destiny. Antarctica is not just a passive victim of climate change, but an active, evolving landscape with its own internal drivers. The secrets of these subglacial caverns and the heat that forms them are not just matters of scientific curiosity. They are in fact crucial pieces of the puzzle in predicting the future of our planet's climate. As we uncover more about these hidden worlds, we gain vital insights into the resilience and vulnerability of Earth's most remote continent. High above the Antarctic plateau, a giant balloon drifts silently, carrying a sophisticated array of antennas and sensors. This is the Antarctic Impulsive Transient Antenna, or ANITA, a cutting-edge experiment designed to scan the vast, pristine ice below for fleeting traces of high-energy particles from the cosmos. ANITA's mission is to detect neutrinos, those ghost-like, nearly massless particles that travel across the universe, rarely interacting with anything. By listening for the faint radio signals produced when a neutrino collides with the Antarctic ice, scientists hope to unlock secrets about the most energetic events in the universe. But, in the course of its search, ANITA has stumbled upon something far more perplexing. On several occasions, the balloon's instruments have picked up strange, powerful radio bursts that seem to be rising up from deep beneath the ice, rather than coming down from space as expected. These signals are not just unusual, they appear to defy the very laws of physics, as we know them. The radio bursts have the signature of a particle shower, but the direction and energy suggest they're coming from below. as if something has travelled all the way through the Earth and emerged from the Antarctic ice. According to the standard model of particle physics, this should be impossible. High-energy neutrinos, the only known particles capable of producing such signals, simply cannot pass through the entire dense mass of the planet without being absorbed or scattered. Yet the data from ANITA is clear. The signals are real, and they don't match any known background noise or experimental error. Scientists have pored over the data, double-checked the instruments, and even considered the possibility of unknown properties in the Antarctic ice that might reflect or distort the signals in unexpected ways. The scientific community has launched a flurry of investigations. Teams have analyzed the radio wave patterns, compared them to computer simulations, and even conducted follow-up experiments with other detectors, like IceCube, buried deep in the Antarctic ice. So far, no conventional explanation has held up. Some researchers suggest that the signals could be the result of rare, upward-going cosmic rays, or perhaps a previously unknown interaction between particles and the unique structure of Antarctic ice. Others have proposed more radical ideas: the existence of a new, undiscovered particle that can pass through matter almost undisturbed, or even the possibility that the signals are evidence of physics beyond the standard model. Among the most tantalizing hypotheses is the sterile neutrino, a theoretical particle that interacts even less than regular neutrinos, slipping through the universe almost completely undetected. If sterile neutrinos exist, they could explain the mysterious signals, and even shed light on the nature of dark matter. Some theorists have gone further, speculating that the ANITA signals might be hints of extra dimensions, or even parallel universes brushing up against our own. While these ideas remain firmly in the realm of theoretical physics, the mere possibility has sparked intense debate and excitement. The ANITA anomaly has become a modern scientific enigma, inspiring new experiments, international collaborations, and a wave of journal articles and conference presentations. Researchers are now designing more sensitive detectors, refining their models, and searching for similar signals in data from other parts of the world. Whatever the true explanation, these strange radio bursts are a powerful reminder of how much we still have to learn about the universe. Antarctica, with its transparent ice, radio silence, and unique position at the Earth's pole, remains the perfect natural laboratory for probing the unknown. As the sun rises over the frozen plateau and the research balloon drifts on, the mystery of the ANITA signals endures, a cryptic message from the cosmos, or perhaps from deep within our own planet, challenging us to push the boundaries of science and imagination. Even in the 21st century, the silent, frozen landscapes of Antarctica hold secrets that could reshape our understanding of reality itself. The search for answers continues, and with each new discovery we come one step closer to unlocking the profound mysteries beneath the ice. Antarctica's isolation and inaccessibility have made it a fertile ground for conspiracy theories, legends, and tales of secret activities hidden from public view. Over the decades, the continent has drawn explorers, governments, and even secret societies, all seeking to uncover or conceal its mysteries. One of the most persistent of these stories revolves around Nazi Germany's expedition to the continent in 1938–39. The mission, shrouded in secrecy, has become the subject of endless speculation. Officially, the mission's purpose was to survey a section of the continent for a potential whaling station, a territory they named New Swabia, but some historians suggest the true objectives may have been far more complex. The expedition extensively mapped a large area and dropped thousands of markers bearing the swastika to claim the land for the Third Reich. Some believe these markers were also meant to signal secret landing sites for future operations. However, the official story has long been overshadowed by more sinister and elaborate theories about their true intentions. Whispers of hidden agendas and covert research have persisted for generations. The most popular of these theories suggests that the Nazis were not just looking for whaling grounds, but were constructing a secret military refuge, Base 211. Some even claim the base was equipped with advanced laboratories and hidden hangars. This mythical base was said to be hidden in a geothermally heated, ice-free oasis deep within the continent. The idea of a warm, habitable zone beneath the Antarctic ice has inspired countless expeditions and scientific studies. According to the legend, it was intended as a last redoubt for high-ranking Nazi officials, including Hitler himself, after the fall of Germany. Some stories even suggest the base continued secret operations long after the war ended. Some versions of the story go even further, claiming the base was a center for developing advanced top-secret technology, such as the Vril-powered flying bell, a supposed anti-gravity craft. These tales have inspired books, films, and even video games. While there is no concrete evidence to support these claims, the story has captured the public imagination for decades. Sensational headlines and popular media have only added fuel to the fire. These rumors were further fueled by a massive and somewhat mysterious American military operation called Operation High Jump, which took place in 1946–47. The scale and secrecy of the mission sparked new waves of speculation. Officially described as a cold-weather training exercise, the operation was a full-scale naval deployment involving an aircraft carrier, 13 other ships, and 4,700 personnel. Some believe the true goal was to investigate or neutralize the rumored Nazi base. The mission, planned to last for 8 months, was abruptly terminated after only 8 weeks. The official explanation was the early onset of winter, but many remain unconvinced. The official reason was the early onset of winter, but rumours quickly spread that the task force, led by the famous polar explorer Admiral Richard E. Byrd, had encountered hostile advanced aircraft that forced a hasty retreat, allegedly engaging in a battle with remnant Nazi forces or their alien allies. Adding to the legend is the alleged secret diary of Admiral Byrd, which purports to detail an incredible encounter during a flight over the pole. The diary's authenticity remains hotly debated. In this contested account, Byrd claims to have flown into a lush green valley and met with an advanced Nordic-like race of beings who lived in a subterranean world. The story echoes older legends of lost civilizations beneath the ice. These beings, the diary claims, warned humanity about its destructive path with nuclear weapons. Similar warnings appear in other polar myths, suggesting a deeper connection between Antarctica and humanity's fate. While most historians dismiss the diary as a work of fiction, these stories, combined with the real-life mysteries of Operation High Jump and the Nazi expedition, have cemented Antarctica's reputation in popular culture as a place that holds deep, dark secrets, a land where history and legend collide beneath the ice. The Cold War era brought new layers of secrecy, as both Soviet and American teams raced to uncover the continent's secrets. Reports of strange magnetic anomalies, unexplained disappearances, and hidden lakes only deepened the intrigue. In recent years, scientific expeditions have uncovered subglacial lakes, ancient microbes, and even unexplained signals from deep within the ice. Each new discovery blurs the line between science and legend, reminding us that Antarctica's hidden histories continue to shape our understanding of the world's last true frontier. The incredibly strict rules governing access to Antarctica are not born from a desire to hide secrets, but from a profound understanding of the continent's extreme fragility, its critical importance to the entire planet, and the complex web of international interests that surround it. Antarctica is unique not only for its environment, but also for its status as the only continent without a native human population or sovereign government. Its future is shaped by science, diplomacy, and a shared recognition of its global significance. The Antarctic environment is one of the most pristine left on Earth. and it's exceptionally susceptible to human disturbance. Even the smallest impact can have outsized consequences. For example, the introduction of a single invasive plant or insect could irreversibly alter local ecosystems that have evolved in isolation for millions of years. In the intensely cold and dry conditions, decomposition happens at a glacial pace. A single footprint left in a delicate moss bed can remain visible for decades, and discarded waste could persist for centuries. The legacy of early explorers' camps, with their abandoned supplies and even human remains, still lingers on the landscape as a stark reminder of how little the environment can recover. The introduction of non-native species, even microscopic ones carried on boots or equipment, could trigger a catastrophic collapse of the unique, finely balanced ecosystems. That's why strict biosecurity measures are enforced, and why every piece of equipment must be meticulously cleaned and disinfected before entering the continent. The stringent regulations are therefore a form of quarantine designed to protect not just the continent itself, but the priceless knowledge it holds for all of humanity. The Antarctic Treaty, signed in 1959 by 12 nations and now supported by over 50, enshrines this principle. The continent is to be used exclusively for peaceful purposes and scientific research. The treaty also freezes territorial claims and prohibits military activity, mining, and nuclear testing. This unique legal framework prevents any one nation from exploiting Antarctica's resources, but it also means that access is tightly controlled and monitored by an international community. The continent serves as a vital natural laboratory for science. Its ice cores contain a perfectly preserved record of Earth's climate and atmosphere stretching back nearly 1 million years, providing invaluable data for understanding climate change. International collaboration is essential here. No single country could undertake the massive logistical and financial challenges alone. The discoveries made in Antarctica have global implications. For example, the ozone hole was first detected here, leading to worldwide action to phase out ozone-depleting chemicals. Its unique microbial communities, like those in Lake Vostok and Blood Falls, could hold the keys to groundbreaking medical and biotechnological discoveries, including new antibiotics or enzymes that function in extreme cold. To allow uncontrolled tourism or industrial activity would be to risk contaminating this irreplaceable scientific resource forever. The number of tourists is strictly limited, and all activities are carefully regulated to minimize impact. Even so, the growing popularity of Antarctic cruises has raised concerns about accidental introductions of invasive species and pollution. The fortress-like access is also a response to the continent's extreme hostility. Antarctica is simply the most dangerous environment on Earth. Temperatures can plummet to below -84 degrees Celsius, and the continent is home to katabatic winds, where cold, dense air hurtles down from the polar plateau at speeds exceeding 320 kilometers per hour. Blizzards can appear with little warning, creating whiteout conditions that can last for weeks, making travel and survival impossible even for the most experienced polar explorers. Rescue operations in such conditions are extraordinarily difficult, expensive, and life-threatening for the rescuers themselves. The strict permitting process ensures that anyone who ventures there is fully prepared, self-sufficient, and understands the immense risks involved. This is not just about individual safety, but about preventing situations that could require dangerous and costly international rescue efforts. Ultimately, the restrictions are in place because Antarctica plays a crucial role in regulating the entire global climate system. Its massive ice sheet reflects sunlight back into space, helping to cool the planet, and its seasonal sea ice drives major ocean currents that distribute heat around the world. The stability of this ice is directly linked to global sea levels. If Antarctica's ice were to melt significantly, it would raise sea levels worldwide, threatening coastal cities and entire nations. Protecting the continent from localized pollution, physical disruption, and other human impacts is not just an act of environmental conservation, it is an act of planetary stewardship. The fortress-like access is a necessary measure to safeguard a cornerstone of the Earth's life support system. In a world where geopolitical tensions often run high, Antarctica stands as a rare example of international cooperation, an unspoiled wilderness, protected for science and for the benefit of all humanity. Antarctica remains one of the last true frontiers on our planet, a place where the boundaries of our knowledge are constantly being pushed back. It is a land that resists easy answers, where every expedition uncovers new mysteries and deepens our sense of awe. It is a continent of profound contradictions, a desolate wasteland that harbors vibrant, hidden ecosystems, a place where life clings to the edge, adapting in ways we are only beginning to understand. A land of peace governed by international treaty, yet also the subject of intense geopolitical maneuvering and scientific rivalry. Antarctica is a stage where nations cooperate and compete, drawn by the promise of discovery and the potential for untapped resources. It is a pristine natural laboratory rumored to hide the remnants of secret histories and advanced technologies. Some even speculate about lost civilizations or extraterrestrial visitors, their traces locked beneath the ice for millennia. Every new discovery, from subglacial lakes to anomalous radio signals, seems to generate more questions than answers, fueling theories about what might still be hidden below. The sense of mystery that shrouds the southern pole is only deepened by the vast, uncharted expanses and the strange phenomena that defy explanation. The continent's allure lies in this very sense of the unknown. It is a place where the imagination runs wild, and where the line between science and speculation often blurs. Antarctica is a physical manifestation of the blank spaces that still exist on our map of the world, a reminder that there are still places left to explore. While we have photographed its surface from space and drilled deep into its ancient ice, our understanding remains superficial. The vast majority of the landmass beneath that ice remains less explored than the surface of the Moon. Some scientists even propose that entire mountain ranges, ancient river systems, or even meteorite impact sites could be waiting to be found. What other vast lakes lie undiscovered? Could there be entire ecosystems isolated for millions of years, thriving in the darkness? What unique life forms have evolved in the warmth of hidden geothermal caves? Some theorize that these environments could even offer clues to life on other planets like Europa or Enceladus. What secrets about Earth's geological and climatic past are still locked away in the rock and ice? Could the next breakthrough in climate science or the story of a mass extinction event be hidden here? These are the questions that continue to draw scientists and dreamers to its shores, each hoping to be the one to unlock a new chapter in the story of our planet. This enigmatic character is amplified by the tangible veil of secrecy and restriction that surrounds it. The difficulty of access, the presence of military contractors, and the strategic positioning of nations in anticipation of the 2048 treaty review all contribute to an atmosphere of intrigue. Some even speculate that the true extent of what has been found beneath the ice is kept secret for reasons of national security or scientific advantage. While the official reasons for this control are based on sound environmental and safety principles, the effect is to create a sense of a forbidden kingdom, a place where only a select few are permitted to enter. It is human nature to wonder what lies behind a locked door. And in Antarctica, the door is guarded by international treaties, immense cost, and the most unforgiving environment on Earth, making the secrets within seem all the more profound. Ultimately, Antarctica's importance transcends the myths and mysteries. It is a living laboratory for understanding our planet's systems and a proving ground for new technologies like autonomous robots and remote sensing that may one day help us explore other worlds. It is a critical barometer of our planet's health and a repository of its deepest history. Some even believe that the next great leap in our understanding of Earth's past, or its future, will come from beneath the Antarctic ice. Its fate is inextricably linked to our own, through its influence on our climate and sea levels. The choices we make about Antarctica's future may well determine the fate of coastal cities around the world. As we continue to probe its secrets, new technologies like AI-driven exploration, deep ice drilling, and even quantum sensors promise to reveal what has long been hidden. We are not just exploring a remote continent, we are exploring the limits of life, the history of our world, and the future of our civilization. Some even dream of a time when Antarctica's secrets will help us survive on other planets, or when its resources might be tapped to support humanity's expansion beyond Earth. For all these reasons, Antarctica will likely remain for the foreseeable future Earth's greatest enigma, a silent white giant at the bottom of the world, guarding its secrets beneath miles of ancient ice. And perhaps, as we look to the future, Antarctica will not only reveal the story of our past, but also inspire the next great leap in human discovery. But beneath the continent's icy veneer, life endures in astonishing forms. Antarctica's unique wildlife has evolved to thrive where few others can. Emperor penguins, the only birds to breed during the harsh Antarctic winter, huddle together in vast colonies, sharing warmth and braving months of darkness and sub-zero temperatures. Their streamlined bodies and dense feathers act as natural insulation against the relentless cold, while their ability to dive over 500 meters allows them to hunt for fish and squid beneath the frozen sea. Leopard seals, formidable predators of the Southern Ocean, patrol the icy waters with agility and power. These solitary hunters rely on a thick layer of blubber for warmth and can slow their metabolism to conserve energy during lean times. Weddell seals, on the other hand, use their strong teeth to maintain breathing holes in the sea ice, enabling them to survive where oxygen is scarce. Yet some of the most remarkable survivors are invisible to the naked eye. Microorganisms, bacteria, algae, and even tiny animals flourish in places once thought utterly inhospitable. In subglacial lakes, isolated for millions of years, scientists have discovered entire ecosystems powered not by sunlight but by chemical energy from rocks and geothermal vents. These extremophiles possess unique proteins and cellular structures that protect them from freezing, desiccation, and intense pressure. Recent research has unveiled how these creatures cope with the continent's extremes. Some Antarctic fish, for example, produce antifreeze proteins in their blood, preventing deadly ice crystals from forming. Microbial mats found in frozen lakes can enter a dormant state during winter, reawakening as soon as sunlight returns. Each discovery reveals new strategies for survival and adaptation and challenges our understanding of where life can exist. The resilience of Antarctica's wildlife inspires scientists to search for life in the most unlikely places, on other planets, beneath the ice of distant moons, or in the frozen depths of our own world. In the end, the continent's greatest secret may not be hidden civilizations or alien visitors, but the astonishing tenacity of life itself, a testament to nature's ingenuity and a reminder that even in the most extreme environments, life finds a way. Antarctica, once thought impervious to change, now stands at the front line of a rapidly warming world. Over the past decades, satellite imagery has revealed a stark transformation. Glaciers and ice shelves, some thousands of years old, are retreating at unprecedented rates. The mighty West Antarctic ice sheet, in particular, is losing mass, contributing to rising sea levels that threaten coastal communities worldwide. But the impact doesn't end with melting ice. As temperatures climb, Antarctica's delicate ecosystems are shifting. Species adapted to the extreme cold, like krill, a keystone of the Southern Ocean food web, face uncertain futures as their habitats shrink and invasive species arrive. Scientists have observed changes in penguin populations and the movement of marine life, signaling a continent in flux. In response, the global community has mobilized. The Antarctic Treaty System, originally designed to preserve peace and facilitate scientific cooperation, now serves as a framework for environmental stewardship. International teams work together to monitor ice loss, study climate patterns, and protect vulnerable species. Agreements ban mining and strictly regulate tourism, aiming to minimize human impact on this fragile land. Still, the future of Antarctica is unwritten. Will the world act swiftly enough to curb greenhouse gas emissions and safeguard the continent's icy wilderness? Or will rising temperatures reshape Antarctica forever, with consequences echoing across the globe? One thing remains clear. The fate of Antarctica is intertwined with our own. Its vast, frozen expanse is both a warning and a hope, a reminder that the choices we make today will shape the legacy of this extraordinary place for generations to come.